Where is
Okay, so let me go over these problems with you guys.
where is that? Oh, that was our.
That was the homework I assigned. This is what you guys are asking about, right? Or you guys want the classwork?
Wait, what do you- Oh, the last one, do this?
You want to go over the classwork first, or? Okay.
No.
Well, let me just go over a couple of these problems here to make sure we're comfortable with this. So when you see this here, all this means is you plug one expression into another expression. So when you see f of g of x, think of it like this: f question mark equals something, right? Now, right now, what is f of x? It's x minus 5, right? So let me put an x back in here. So right, so what are you replacing the x with? With g of x, right? So you want f of g of x. It's going to be g of x minus 5. And what's g of x, guys? 4x plus 3. And of course, there's a minus 5 at the end, so you get 4x minus 2. That's all. Just takes a few seconds. So the rest of these problems all work the same way on this page. AJ, go ahead.
So is it the same thing as what you just did above?
I'm sorry, repeat that one more time.
For 3, it's like this 6, not 6. Did I say 6?
Yes, you did 6. That was confused.
Sorry, that was my bad. The G times
Okay,
F, is
yeah.
that the same thing? Or is
Yes, so that's not times. That's actually a composite. So when you see a circle with a hole in the middle, or like an open circle, that's like saying this, guys. It's the same exact thing as saying this. So what you do is you got to take where f is and throw it into g. So here's what you're going to do. Instead of x cubed, what are you cubing now? The g. Sorry, the f. And instead of 5x, you're doing 5 times what? That's it. And you can leave your answer like that, by the way. So Haley, where you may have taken a long time, and that's my fault, because I probably should have made it clear in the instructions. Did you expand something like this?
Is that number 3?
Yeah, did you wind up foiling that?
Wait. Yeah, I did.
Okay. Not necessary. You don't have to do that. I'm totally fine to leave your answer like this.
Can you go over like the last few where you were
Okay.
getting solid numbers? I had
Okay,
variables in my answer.
let's take a look at that one.
I didn't realize that you had put the variable for like the x.
Okay.
So can you you get your g of x or whatever, or g of f, whatever it is, and then add that number into the variable?
Well, so like, want to give me a specific number to work on? Like maybe number, like you want to do 11 or?
Yeah, they did a-
Okay. Okay, so guys, quiet please. So 11, right? Oh, Cam, do you need notes? And that's you got everything? Okay, got it. You got everything? Okay, great. So what this means right here, you got to plug 0 into g first, because g is closest, right?
Why?
Because it's closest. Because it's closest. That's why. Because g. So when you see something like this here, the 0 goes into g first.
So you ignore like the g of the f.
Whatever g of 0 is, we'll go into f afterwards.
Oh.
So let me rewrite it. It's the same thing as saying this. F parentheses g parentheses 0, then 2 more parentheses. It's like saying that. So you plug 0 into g first. That's easy. That's just what's g of 0? If you plug 0 for x into g, what do you guys get? 1. Good. So now, what does this equal? F of 1.
Plug in 1 for x.
Done. That's it.
I took a photo of that.
Absolutely. I'm recording this too.
Oh,
Yeah,
okay.
yeah.
Then I'll watch the prints. I did the whole last half of the
That's it.
homework wrong. I didn't realize 0 went in for a variable. I
Yeah.
thought it was I thought it was like you distribute it and then you get like 8x squared plus.
So it's a misconception. We're clearing it up.
Okay.
That's all. Yeah.
Well, that's actually easier.
Told you. Yeah, it's always easy. You guys nothing to worry about. Now
Okay.
13 is a little weird because 13 has 2 identical functions. So you got to plug 2 into g, and then where that is It's kind of like in middle school, they teach about the function machines. You plug something into a function, the output becomes input for the next function. It's kind of the same thing. So this is G of 2, right? Huh?
Times 2t plus 5 plus 5.
So you do that first, which is 9, of course, right? That's G of 2, of course. And then you got to plug it in again, right? Then you got to do 2 times 9 plus 5, which gets you what, guys? That's it, done. That's all you got to do. Now let's move on to maybe some of the bottom, perhaps. I mean, they're all kind of the same thing. What are the other ones you want to talk about? They're confused about, or does it all make sense? Yeah, Elizabeth, go ahead. For what number? Okay, let's look at number 20. And Isabel, did you have a question about one of these that you want to ask about, or? Okay, let me do 20 right now, and we can look at the other 3. Okay. So again, guys, it's just arithmetic. That's all it is. G of H of -4. Right, so if you work that out, you get 9. Then you get, yeah, should we 12? What would the answer key say? The answer key could be wrong. Let's see. Yeah, wait. Hold on. Yeah, plug in -4 into n. That's 16 minus 5. Oh, wait, we did H of, we did it wrong. You told me the wrong answer.
Oh, sorry.
It's okay. Okay, let's do H of -4 again. What's 16 minus 5?
I got 13. I don't know.
It's 11. You put 9. Yeah. It's okay, it happens. It happens.
-4.
Yeah. So it's 14.
Okay. There's 11 ones.
Yeah, so Elizabeth made a careless error. That's all it was. I'll explain it again. No problem. Okay. So here's the deal. I'll do it on the board. To get G of H of -4, right? So you gotta put -4 into H. So that's -4 squared. 16 minus 5 is 11, of course, right? Then you gotta plug into n. 11 plus 3 is 14. That's all.
I don't pull it.
That's it.
You're gonna pull it out.
So let's do it 3 more times. Roll kill, right? Let's look at this one up here. Plug -10G, that's 100 minus 40, which is 60. Plug in 60 into F, -2 times 60 minus 3, -123. Let's do it again. Plug in -1 into here, you get negative of -1 squared minus 5, which would be -6. Plug in -6 into that. You end up getting -41. Do it again. Plug -1 into here. G of -1 is going to be 1. Plug a 1 to that. It's 6. So all you're doing is you're plugging the number into one function, wherever that output is, becomes an input for the other function. Exactly. That's it. Yes. Yes. So that's all that's going on for that. I don't know. That sounds kind of funny. Okay, so that's kind of what's going on. But let me go back to the notes again, see if you guys have questions about the notes. Let me pull it up here. Give me 1 sec. And we're going to do 6-4 today also. Yeah, who's laughing really loud? It's really funny. Anyway, chapter 6. No, it's like from the other room. It's from the study room, I think.
Yeah.
I don't know what's going on. All right.
I actually don't.
Okay, guys, let's talk about this stuff here. I want to read, guys, quiet, please. So there's 3 main things for this unit. So 6.1 was on simplifying exponents, understanding how to go from exponent form to radical form. 6.2 was on simplifying radicals, solving radical equations, and then you have this stuff. So when you see something like part A, I mean, it's pretty obvious you're multiplying f and g, right? So just 6x times x to the 3/4, right? That's pretty easy, not that hard. And if you want to simplify, you can say 6x to 7/4. Sure. And B is pretty easy. You just put one on top of the other, right? Not that hard. And you could simplify it. How do you simplify that?
X to the what?
6x to what power? 1/4. Because if you don't see an exponent, you assume it's 1, right? And you subtract it.
You have to make the bottom square. So then you get.
Yes, you make that 4/4 minus 3/4. Now, this is part C is the part I care the most about because that's a skill you guys haven't really seen. And it's a very important skill to have moving forward as you guys take pre-calculus next year and calculus year after. Patrick, go ahead.
So Mr. Morris
Mhm.
said that we could do like the infinity notation thing
Yes.
for those.
Yes, but how you write domain. So what Mr. Morris taught you guys was interval notation, which actually I like a lot too and prefer. I'm gonna be pretty open about how you guys write domain in the beginning, but eventually we're gonna adopt some standard. The standard being what Mr. Morris taught you guys. But here's the deal with domain. Yes, domain can be a little tricky. It's really two things you gotta watch out for. And I'll put as a text box here. For domain, and put this in your notes. Watch out. Whoa, that was loud. All right. And pick these on the gun, please. Thanks. A little distracting. All right. Domains can be all the X values you're allowed to plug in.
You can't take it out.
So you can't have a special little box on the bottom and you can't have an negative on the bottom.
Hold on. Let me write out first.
It's
Can't divide by 0.
You can't have an exponent at the bottom.
Can't square roots
Negative.
negative numbers. Okay. And these are things you guys already know. I mean, you guys have known this for a long time.
You can have a square root on the bottom if it's.
I don't care about that. It's what I care about is I don't want you plugging a number in that won't give you an answer. That's what domain means what you're allowed to plug in to the function. That's what it means. So domain's gonna be all the X values you're allowed to have. Is there questions, Phil? Or the ones that you guys already have, no? Yeah, right? Yes, okay, so let's take a look at this. And actually, let me rephrase that. Instead of square root, let me rephrase that. Can't even root negative numbers. Now, guys, quiet please. Let's back up a little bit here. How come you can't divide by 0? Like, I mean, I know, like, generally speaking, like 10 divided by 2 is 5. Because 10 equals 2 times 5, right? That's not that hard. I know that, right? But 4, can I multiply a number by 0 and get 4? No, because anything times 0 is 0. That's why you can't divide by 0. Also, square root of -16 is gonna be imaginary, right? That'd be 4i times 4i, which I know you guys did while I was on leave. But you can't find two identical real numbers that multiply to negative. It's not possible. So whenever you're even rooting, you have to make sure you're not even rooting negative numbers. You can't divide by 0. Fortunately, X is on the bottom of it anywhere here, right? So we don't have to worry about that. After I simplified it, I don't have to worry about that. But I have to guarantee that this is positive. This has to be positive. And actually, technically speaking, because there was initially an X beginning here, you probably don't want 0 also because if we're plugging 0 in the beginning, that could be a problem. So bottom line is this: you can't divide by 0, that would be bad. You also can't even root negative numbers, that would be your domain. Domain would be actually greater than 0. Those are the only two things you have to ever watch out for: is even radicals and X in the denominator of a fraction. That's it. You could, but because initially, there's an X in the bottom of the fraction here. I can't divide by 0. You're right, the simplified form doesn't have this. You're right about that. But taking a step back, if there's any place where when I do plug in 0, I can be divided by 0, that's an issue. I'm gonna make sure I exclude that from the domain. So we'll practice more domain. And what I'll do, even starting Monday, I'll start infusing some more review stuff with you guys anyway to get you ready for the test on Friday. And again, small test. Is spell good?
Is it just X squared?
Just X is greater than 0.
Could I write out X as?
Sure. Sure, that's fine. That's fine too.
It
But-
can't be equal though.
Yeah, because if it then equals 0, then it'd be divided by 0 over here. That'd be a problem.
And then, so for the one that was f of x plus g of x. I don't
That's
know
up
what
above.
that is. I think that's
Things up above. Yes, this one right here.
why,
Okay, let's look at that one.
what's the reason why?
So obviously you're just adding the 2, right? So by the way, that's 4 root x plus minus 9 root x. So that's negative 5 root x. So now you want the domain for that. Here's the deal. You don't have a fraction, so don't worry about fractions, right? But it's an even radical. You can't have negatives.
Oh,
So it's got to be greater than or equal to 0. Now, did Kimo teach you guys this technique? Yeah. Okay. Does that make sense to you guys, or do you have questions about it, or? Okay, that's called interval notation. This is the preferred notation. We move on to pre-cal and calculus. I'm gonna not assess this for this test, but I will ask you guys to use this for future stuff later this spring. But what this means, it's not that hard actually. The bracket means the 0 is included. The parentheses means the 0 is not included. And when you're going from 0 to infinity, think about the number line. 0 being the middle of the number line, and where's infinity? Way out here, right? So if you're plot this on a number line, obviously it would start here. And where would you shade if you're going x is greater than or equal to 0? You shade to the right. So that's why you write it like that. You write 0 first, infinity afterwards, to show you going from 0 and beyond.
would it infinity be first?
No, because 0 is less. You always write the lesser number first, the greater number second.
It can't.
That's negative infinity. That'd be negative infinity. You put negative symbol front. So this, and infinity is not even a number, right? So that's why I don't have a bracket around it, because I even know what infinity is. It's an abstract idea that number just goes on forever.
And then never mind. You did it.
Okay, good. But okay.
Yeah, I was gonna say it doesn't matter. If it's black, it's worth it.
No, you have to put parentheses.
If it's-
But if you know what AJ was saying, if you want to write out verbally, that's fine. If you want to write as an inequality, that's fine. Initially, I'm fine with how we write. Ultimately, we're going to have to embrace the interval notation, because that is the notation that most mathematicians use for future math classes. Those be good. Exactly. Yes. Yes. No, if it was all real numbers, you can write all real numbers. That's fine. Some people write an R with a line through it. That's fine. Or you could write this.
But why is that like from like not included, but
Because what is infinity? We don't know. We have a bracket that means it's a number you know exactly. I don't know what infinity is exactly. I got no idea.
doesn't.
Okay, I think we can move on to our new topic on 6.4. Well, and I'll make sure you know, I'll have some review stuff ready for you guys next Monday. Patrick, go ahead. Oh, sure, yeah, go ahead, yeah, totally, yeah. Okay, so let's move on to 6.4. So in these same notes, let's go to 6.4 part 1. And I'm just gonna cover I'm only gonna do part 1 today, not part 2. I think it's a little too much.
Mr. Yi,
What's up?
for the test,
Hmm?
will it be like a strict 30 minutes, like you have, like, taken away as
No, it's not.
Generally.
Well, I mean-
Failure.
I'll put it this way, I'll make sure you could do it in 20 minutes. Put it that way. So it means I should be able to do it in 2 minutes or 3 minutes. I just for a living, I do fast, I work math fast, that's all. So I will make sure, it's put this way, Mr. Gilmore shared a copy of his test with me that he's giving tomorrow. It's only 2 pages. You could do 2 pages in 30 minutes, right? I'm pretty sure you could do 2 pages in 30 minutes. You should be able to. So it's just gonna be like that. So all right. Sure, yeah, totally, yeah. Okay, I'm only gonna do the first couple of pages. And I think what I'll do to help ease your fears about the test next week, the homework I'll assign will be a 6-1 to 6 review over the weekend. How about that? Okay. So instead of I still gotta teach 6-4 just to feel comfortable that I'm not falling behind. That's for my own sanity. But the homework I'll assign for the weekend will be stuff on 6-1 to 6-3. So you guys get more of that practice, okay? So I'll make sure you guys get that practice, which we can talk about on Monday. We'll do more of 6-4 and maybe some 6-5 on Monday. And then Wednesday next week's all review. So you had a question to spell or you good? Okay. All right, so let's talk about and we'll get to the first 2 pages here. Pages 8 and 9. Okay. Everything okay? Matthew, you're okay? Okay, good. All right. All right, inverses. Okay. When you guys hear the word inverse, what do you guys think of? Yeah, opposite, exactly. Yeah, it's like opposites. Totally. Hey guys, Charlie Matthew, stop talking. All right, thanks. Okay. So exactly right. Word opposite division would be multiplication. And Cam, stop looking, Matthew. Thanks. Opposite square rooting. Squaring. Opposite of cubing. Yeah, cube rooting, exactly.
Wait, what is the third one say?
Squaring. Yeah, that's hard to read, sorry.
And then the other one says.
You know, let me do this. I'm gonna write better. My mouse is a little too sensitive here. I'll fix this. Subtraction. Multiplication. Squaring. Cube rooting. Let me just adjust this. There we go. Hope that's better. So, I mean, you guys, this should be pretty intuitive, nothing new. What this means is that when you find the inverse function, that's what we're going to work on today. And by the way, this plants the seed for what we're going to do after we finish chapter 6. As I said, like sometime in March, we have the SJTI. We'll have a second half of chapter 6 test, like right from the SJTI on March 9th. After that, on March 10th and all March, we're going to be working on a new topic called exponential functions and logarithmic functions. Ask any of your siblings, if you have older siblings or any old friends who are juniors or seniors or much older who took this class, and you mentioned logs, their eyes might bulge out of their heads. Because logarithms is a pretty tough topic. And sadly, that was the topic we had during the pandemic 3 years ago when I taught this class, which is really awful. And they didn't really learn logs very well. But in order to understand logarithms, it's a really complex topic, which we're going to do later in March. We have to understand inverse functions first. Inverse functions is the foundation that we need to understand the stuff we need to do much later. Okay. But for now, we're going to keep this pretty basic, pretty simple. So here's how you find inverse.
Wait, 6.4 is not.
Non-test. Okay. So when you find the inverse, it's really 2 steps. It's 2 steps. Step 1, swap X and Y. And 2, isolate Y.
You just flip their position.
Yep, and get Y by itself. Yep.
Wait, isn't that how it already is though?
No, I'm gonna switch it right now.
So are you not switching to -5?
No, what you're doing first
is you swap X and Y. After you swap X and Y, then you're gonna isolate Y.
Now, this is where you do the inverse operations, which again, you guys know this because you guys have been solving equations for the last 3 or 4 years, right? How would I isolate Y here? What would I do? Because 5 is adding 5 is the inverse of subtracting 5, right? So X plus 5 equals 3Y. And then since Y is being multiplied by 3, what's the inverse of multiplying by 3? So what does Y equal? Y equals X plus 5. So this right here yes, is the inverse of Y equals 3x minus 5.
Why do you? What's the benefit?
So that's the same, later in March, we get to this new topic called logarithms. In order to understand that topic, we need to understand this process of inversions. I know, it seems very elementary, like why it doesn't seem significant, especially will be separate things. Oh, it's guessing pH.
Really, half-life.
Oh, half-lives, yes.
But
Okay.
you know,
Are we just plugging
maybe
stuff?
they didn't have the box.
You can replace it with negative 0.69.
Plug it, drag it.
Set,
Okay.
which I don't know, I used the graph, like divided by 2.
Okay. Now, really quickly, just a quick fun way for this. Take a quick look at the final expression. That's why. So the original equation is 3 times x minus 5. Obviously, what's the addition of subtracting 5? 10 and 5. The inverse of multiply by 3. By 3. And also the order is reversed too. Order of operations, you multiply and subtract, right? Here, obviously we're adding because it's up top.
Can you just look at it and figure it out?
Yeah, you could. You could.
But sometimes they get a little more complicated, like in number 2. Let's move on to number 2. And then we'll do number 3 after that. Yeah, why? Good. Sure, yeah, of course. All right, so you switch X and Y.
Can I get some water?
Oh yeah, yeah, totally.
I like this.
Sorry, go ahead. Yeah, do what you gotta do. Okay, X equals Y cubed plus 4, right? Okay, so after you swap X and Y, we gotta get Y by itself. What did I do to get Y by itself? I should probably subtract the 4 first. Good. And then cube it, and that's that. And I gotta go here.
Oh, you do the X too, okay. No, you just. Yeah.
So Y is the cube root of X minus 4. So that's the inverse of X cubed plus 4. Okay, let's try this one more time, and then we're going to kind of look at it graphically on the next page. Good, that's nice. And then we're done with the notes for today. So now it's been one day for you guys. All right, it's the same thing, X, a long week. X equals the 5th root of 2y plus 1. Okay, your goal is to isolate Y. What do you think I do? How would I isolate it? Yes, good. Raise everything to the 5th power. So you got x to the 5th. Okay, then we're 2 steps away from getting the answer. What comes next? -1. And then divide by 2. Okay. Now, one thing I want to quickly talk about with you guys, which I'll talk more about on Monday. Let's take a look at just you don't have to say just sit back and watch. Let's see an example. So the original function was this, right? Y equals x plus 4a. The inverse was this. Y equals roots. Okay. Again, we'll emphasize this on Monday. You're okay. So Jim, help me out here. There you go. Well, give me a number to plug in. Why? What I get? 4. No. Okay, give me another number. Give me another number. What do I get when I plug in? 12. And we'll do one more. How about 0? You get 4. Yeah, why would you say?
What's he looking at? No, I was saying, plug in for water. Yeah.
Okay, I'm actually saying 1 by 1. All right, now, here's part of this interesting. If you put 5 in, what do you get? Y. You put 5 in.
That is really difficult.
Put 12 in, 12 minus 4, 2. But if you plug 4, what do you get? What do you notice of these 2 columns?
They're inverse.
They're flipped, as they should be, because they're inverses of each other. So that's gonna be a key idea that we'll talk about Monday, which will be hugely important for what we do in chapter 7 later in March.
Oh, cause is that over?
Yes, exactly. Right.
So we don't need to know this for the test.
No, yeah, 6-4 is on the test. Don't worry. No, this is for just to show you what's happening. We're gonna do this again on Monday. So, okay, let's finish off the notes on the next page. And you guys can just relax and I'll put up the homework again, the homework over the weekend will be a review of 6-1, 6-2, and 6-3 in preparation for a test next Friday. And I'll put it as a Schoology assignment, the test, so it shows up on your end. Okay, another thing that's important to know too about inverse functions, that's kind of tied to what you guys did on Tuesday, composites. If you have this here, so let me write some words. Guys, stop making a mess with the, you guys are like my 6-year-old son does. Come on, you guys are like 10 years old, my son. Stop doing this stuff. Jeez.
Stop blowing me.
It's like there's no maturity from age 6 to 16. So I'm going to have a hard time. Yeah, go ahead. What's going on?
He put his.
All right.
No, he.
Okay, guys,
all over.
just distracted. I want to work. Go ahead. Yes. What do you mean?
Yeah. Anything that's like right here, like this will be these X values in the Y position. No, they're different equations. Yeah.
It just said the columns are switched. Okay, guys, calm down, please. Thank you. Yeah, you tell him, Cam.
Just trying to relax
All right.
here.
All right, and please don't make a mess. Thanks. All right.
I'm going to throw it away.
If a composite function results in X,
No, don't even, that's so.
Well,
That's so
times
fair.
it lasts for less than an hour. So they understand.
Oh, that's.
Okay, guys, here we go. Oh, come on. This thing we go.
Stop. Stop. I don't know where.
Okay,
Stop.
So, guys, quiet, please. So if a composite function, which is this up here, right? You guys talked about it, it came out. The composite function results in X, the final result is X. What that will tell you is that both of the functions involved are inverses of each other. So if this happens, if you f of g of x or g of f of x, doesn't matter, and the final output is x, the two functions are inverses of each other. Now, when I look at these two, I'm pretty sure there's gonna be inverses because that's x times 3 minus 5. What's the opposite of multiplying by 3? And what's the opposite of subtracting 5? So I'm pretty sure this is gonna work. But what you do is this, you do f of g of x, which of course, f of x is 3x minus 5, so you're doing 3 parentheses. And you're not gonna put x, you're gonna put g, so you're gonna put all x in there, right? Does that make sense?
What? That doesn't always.
Hold on, AJ, let me clear it up first, I'll answer your question. So f of g of x means, you know, replace this x here, so instead of an x here, you're putting g there, right? And what's g is all that junk, right? So this goes in x position. So because f of x is 3x minus 5, right? But because g of x is all this junk, you gotta put this into x position.
It's like what we did the other day.
Yeah, totally, yeah, exactly, 100%. And so AJ, go ahead, what are you gonna ask?
I was gonna say to like verify it, is it possible if you just take the two of them and you reset it to Y?
You could do that too, yes, yeah, that would verify it also. I just wanted to show you that this is another way to do it.
That's like.
Yeah, no, but yes, if you were to actually literally find that inverse and it equals that guy, yeah, that's totally fine. Yeah. If you distribute, you get x plus 5 minus 5, you get x. And there you go. If I did it the other way around, if I did g of f of x, I'll get the same thing. I'm not gonna do it kind of redundant, but yeah, that's what happens. So that's how you can verify two functions of inverses when that happens. Or at the very least, if you see this expression, know that f and g are inverses. So you want to be aware of that. I've actually seen stuff like this show up on the AP exam for calculus, which I know you guys are not going to take calculus for a couple of years, but at this time, 2 years from now, if you're going to get calculus AP, if I happen to teach that to you guys, I'll remind you of this because this is something that does appear again later in math down the road. So this expression, just recognize that this means that they're inverses. But to verify what AJ is saying, it's totally fine. You could just also just find this inverse straight up, like I did in the last example, and see if it equals the other one. Okay, let's do one more.
what's going on? All right, one more. Example 5. Okay, let's find inverse. How do I do it?
So you would do.
X.
It's,
And by the way, f of x is the same thing as what letter? F of x is the same thing as saying, yeah, it's the same thing as saying y. So f of x is y, right? We discuss swap. Okay, how do I isolate y? What do I do? Oh my goodness, I'm sorry.
Jeez, I forget. Before I do that, move the 7 over.
Move 7 over first, yeah.
Kind of push it back now.
Guys, enough. Stop it. Matthew, Cam, Charlie. How are you guys even sitting together anyway? I thought I'd moved you guys. Okay, we'll move you guys next week because I don't even know why you guys are sitting together. Well, these guys gotta move, so we'll figure it out next week. All right. Guys, what's going on? All right. So you gotta raise both sides to 5/3. I think listening to this video is gonna be hilarious. Just all the back and forth here. All right. So here we go.
Just leave it out. There's no.
So that's all.
So
5.
Wait, you did, what was the first thing said?
What is that?
Oh, yeah. Oh, that's said separately.
Plus.
That's a huge. So that's the space. It work off. So let me give you a great example. Guys, I am so glad Adrian brought this question. Because my pre-cal students made this mistake on my first day back after a week. And I was really disappointed in my pre-cal students. That's not their fault because they had a pandemic and they didn't learn to study. So here's the deal. If you have 4 plus 5 squares, what's that? Right. But you can't do this, right? That's a totally different thing. What would that be? That would be 41. So it's the same thing. If you have x plus 7 raised to 5/3, that's the best I can do, right?
Yeah.
If I did this, that's a totally different expression.
Yeah. So it's like-
Yeah, because if I were plugging, like say, if I plug in 1, that'd be 8 to the 5/3, which I think would be 32. But if I plug in 1 here, I get a much different answer. So don't do that.
Okay.
Yeah, these are not the same. So that's one. So now I'm glad, Rob, so don't make them sick pre-calculus. So, anyway, okay, so then it says verify that are inverses. I mean, if you did f of g of x, so the verifying part will do really quickly and we're done for today. So f of, oh, by the way, another thing I need to talk about too. You okay, Haley? What's wrong? Oh, you're just coughing a lot?
I'm not even sick, I just have.
It's okay.
that cough.
It's okay. It happens. Don't worry about it.
Well,
I
So-
had
so-
another
sorry.
flu last week.
Oh, it's terrible. That's what I had.
and it just went into a cough. I went to the doctor, said I was,
inquisitive.
That's good.
just that I have like.
Yeah.
Another thing I need to mention too. This notation, by the way, we see after the -1 next to it, it's not an exponent necessarily. It's not like flipping over anything.
Inverse.
It just means inverse, right? It's just a notation thing.
That's what we do when it's a cosine. It's a reverse.
Exactly right. When you guys did inverse trig last year in geometry, right? Yeah, it's the same thing. So exactly.
Right, it like.
No, but I just want to make sure you recognize that. So when I do this right here, guys, quiet, please. I need you to focus. Guys, whoa, come on, let me finish, please. Thank you. All right. So when you see this here, you're plugging the inverse into itself, right? If you do that, you get parentheses x plus 7 raised to the 5/3. But then that gets risen to 3/5, right? Because that's part of the original function. Minus 7. And then these would drop out. X plus 7 minus 7 get to x. That's the verification part. That's when you put this function back into the original. So if I plug this back in the original, just to verify that I got this working right. That's what I was doing. So
Since we got X. Check that.
I haven't decided. Well, first of all, this is not even until March, this test.
Oh, okay.
Okay, guys, remember, 6-4 is not on the test next week. Yeah. I just have to at least get this process started. Okay, so I think that's enough for today.
Like a Zoom before the chapter 5. or chapter 5.
Yeah, I mean, I'm here all week anyway. But I can Zoom with you guys Thursday night if you guys want.
Yeah.
Sure, I can do that. Sure. That's it. Yeah. If you want more, that's fine. Yeah, I don't care. Well, why's your shoe off?
My eyes are up here. Something like.
Yeah, you tell him, Charlie.
Oh,
Thank
Okay.
you.